Assalamu alaikum wa rahmatullahi wa barakatuh. Open your booklet, page number 34. Our lesson today is solving two equations using inverse of matrix. Okay, so we learned before how can we solve two equations with two variables by omitting method in prep 3 and by substitution method. And for this term we learned how to solve them using determinant. So our lesson today is we have to use the inverse of matrix to find the solution set of these two equations. Okay, so let's have the first example here. It is 2x plus 3y equals 7. This is the first equation. The second equation is x minus y equals 1. Okay, so how can we solve them? First of all, we have to arrange the equation. I mean, we have to write 2x first, and then if it's not arranged, we have to arrange it. Okay, this is the first step, because in the next example we will find it not arranged, so we have to arrange it first. Okay, so 2x plus 3y equals 7. So we will confirm a matrix 2 and 3. So this 2 is this one, and this 3 is this one. Okay, and the second equation here, x minus y equals 1, we will take this x and put it here, and negative y means negative 1y. Okay, so we will take negative 1 and put it here. Okay, so 2, 3, 1 and negative 1. This matrix is of order 2 by 2. Okay, so what are the variables or the unknowns that we want to find? They are x and y. Okay, so as we arrange this matrix, x first and then y, we will put here x and then y. The arrangement is very, very important. Okay, and this matrix of the order 2 by 1, we will the answer is 7 and 1. Okay, so we want to find the value of x and the value of y. So as we learned in the previous lesson, how to find this matrix. So we want to find the unknown matrix. So how can we do that? This matrix before the unknown matrix. This one is before the unknown matrix. So it will be here in this side, but by the inverse of it. And because this matrix before x and y, the unknown matrix, when we put it here in the other side, it will be before 7 and 1, before this matrix. Okay, do you understand? So if we have here a matrix by another unknown matrix equals third matrix, how can we find this? How can we find the unknown matrix? Okay, so first we have to know if this matrix before the unknown or after the unknown. So as it's here before the unknown, so when we put it here, it will be before the unknown also. Okay, but by negative 1, and negative 1 means what? Do you remember what is the meaning of this matrix and above it negative 1? Yes, perfect. It means the multiplicative inverse of the matrix. So how can we find the multiplicative inverse of the matrix? First, we find the determinant, the value of the determinant of this matrix. Okay, so we will make it as a determinant, and then to find the value of the determinant, if you remember, we will multiply 2 by negative 1 minus 3 by 1, so the answer is negative 5. And then we put 1 over negative 5 by, do you remember what do we do here? Yes, so we will take the main matrix here, but we will change some things. What are the things that we will change? 2 and negative 1, it will be the converse, negative 1 here and 2 here. Okay, and these two elements we will change their signs, so it will be negative 3, negative 1. Okay, so multiplying 1 over negative 5 by each element of this matrix, the answer is this. So 1 over negative 5, 1 over negative 5 by negative 1, and 1 over negative 5 by negative 3, 1 over negative 5 by negative 1, 1 over negative 5 by 2. This will be the answer. Okay, so x and y equals what? As I told you here, x and y, the matrix x, y equals the multiplicative inverse of the matrix, okay, this one, by 7 and 1. Okay, so what is 7 and 1? This one. As you know, how can we multiply two matrices together? We will do here that. We will multiply this matrix by this one. Okay, so the answer will be x and y, 2 and 1. Okay. Okay, so the answer for the x, or the value of the unknown x, is 2, and the value of the unknown y is 1. So the solution set is 2 and 1. So how can we make sure that is the right answer? We can use the calculator to make sure about this answer, okay, by making a mode EQN1 and then type these two equations. 2 equals 3 equals 7 equal, and 1 equal, negative 1 equal, 1 equal. I think you can make this, or you can solve these two equations using the calculator 991, or I think 500 ms, or something like that. Okay, so how can we make sure the answer of x is 2 and the value of y is 1? Okay, so let's check this answer. 2, so we will put 2 instead of x. 2 by 2 equals 4, so this is 4, plus 3 by y equals 1, so it is 3. So is 4 plus 3 equals 7? Yes, so this is the right answer. And check the second equation, x minus y equals 1, as x equals 2 and y equals 1, so 2 minus 1 is 1. Yeah, this is the right solution. Okay, so let's go to example 5. What do we have here in example 5? We have an equation, x equals 2y minus 1 and 3y equals 2x. Do you notice something? Yes, I noticed. I noticed what? I noticed these two equations are not arranged. We have to arrange them first. So how to arrange? Yes, 2y will go to the other side by negative sign, because it is positive here. So it will be x minus 2y equals negative 1. And the second equation here, it will be, we will take this 3y to the other side by negative sign, so it will be 2x minus 3y equals 0. Okay, so this matrix here is we will take it, or we will confirm this matrix from these two equations. 1 here, because we have x, so x means the coefficient before it is 1, and negative 2y, so 1 and negative 2. And for the second equation, 2x, so we'll put 2 here, negative 3y, negative 3. Okay, and then we have here x and y, the variables. As we arrange them here, we put x first and then y. Okay, so the same here, x first and then y equals what? Equals the solutions here, which are negative 1, 0. Okay, so to find this matrix x and y, the matrix of the unknowns, this matrix here before the unknown matrix, so when we put it here, or when it goes here, it will be before this matrix. So x and y, the matrix of unknowns, equals the main matrix, this one, but negative 1. And as we know, negative 1 here means the multiplicative inverse of the matrix, and then we will multiply it by negative 1, 0. So our mission here, or our mission now, to find the multiplicative inverse of this matrix. The first step to find the multiplicative inverse of any matrix is to find the determinant of it. Determinant, so it will be 1 by negative 3 minus negative 2 by 2, so the answer is 1. And then we will make 1 over 1 multiply the matrix, but we change something. We change what? We change these. Okay, so 1 and negative 3, it will be negative 3 here and 1 down, and these, for these two elements, we will change their signs. So negative 2, this negative 2 will be 2, and 2 will be negative 2. Okay, and then multiply 1 over 1 here by each element of this matrix. Okay, so the answer will be negative 3 to negative 2, 1 by negative 1 and 0. Okay, so the answer will be 3 and 2. X equals 3 and y equals 2. How can we make sure? Yes, excellent. By substituting, instead of x putting 3 and instead of y putting 2 in the main two equations. Try to solve these two equations using determinant. Okay, so use a determinant for the first time and use the multiplicative inverse for the next time, and check your answer and tell me the result. Okay, for the homework, it will be page number 36.